Today we're going to learn about nonlinear equations or functions. Our essential question is, how do I identify nonlinear functions? So let's look at what a nonlinear function is. We know what a linear function is. It's a function whose graph is a line. So a nonlinear function is pretty much the same thing, only it's going to be a function whose graph is not a line. So let's go ahead and write that in our notes. It's a function whose graph is not, making sure we remember it is not a line. So what does it exactly look like if it's not a line? Excuse me. Well, if it's not a line, if you can think of a graph being an XY axis, a nonlinear function would look like something that was curved. So it might look like that. Or maybe you might have a graph that looks like something like this. Or maybe it's all over the place, like that. The two red ones have a special name. They are called a quadratic function. So we're going to talk about these two here. These two are called quadratic functions. And a quadratic function is nothing more than an equation that has an x squared in it. So you might have x squared plus x plus 5 is a quadratic function. When you graph a quadratic function on a coordinate plane, it looks like a U. And if the x squared is positive, the U goes up. And if the x squared is negative, the U goes down. And it could be anywhere on a graph. Those pictures, those U's, have a special name. That name is called a parabola. So anytime you see an equation with an x squared, it's called a quadratic function, and the graph of that quadratic function is a parabola. So a parabola is a graph. A quadratic function is an equation. So keep that in mind. So looking at these three functions, which one of them, or which ones, are nonlinear? So looking at the first one, it's a line. So this one is going to be linear. Looking at the second one, it's a parabola. So I know it's nonlinear. And function 3 is obviously not a straight line. So that is also nonlinear. Now, looking at a table, we can determine if it's linear or nonlinear by looking at the comparison of x to y. So if I look across x, from 2 to 4 is a change of 2, and the y from 4 to 8 is a change of 4. From 4 to 6 is a change of 2, and 8 to 12 is a change of 4. And 6 to 8 is a change of 2, and 12 to 16 is a change of 4. Since these are all equal to each other, this is linear. And we already learned that. So then the opposite must be true. Looking at this, you should write this into your notes. There are two ways of determining nonlinear functions. One is with an equation, and one is with a table. With an equation, by looking at the equation, all you have to do is look for an exponent that is 2 or greater, or a variable as an exponent, and that will tell you it's nonlinear. For a table, you need the ratio between the changes in variables are not the same. So let's look at examples of this. In letter A, we have two examples. Y equals 17 minus 4x. Notice you have a variable in your exponent, so that is non-linear. In the second example, there are no exponents and there are no variables as exponents, so that one is linear. In letter B, we look at the comparison from x to y. So 3 to 6 is 3, 3 to 5 is 2. 6 to 9 is 3, 5 to 7 is 2. 9 to 12 is 3, 7 to 10 is 3. These are not equal, so it's non-linear. 6 to 7 is 1, negative 2 to 1 is 3, 7 to 8 is 1, 1 to 4 is 3, 8 to 9 is 1, and 4 to 3 is 7. So these are linear.